So other property-based improvements, we've got the ground source heat pump. So you need a lot of pipe for this. And basically, as an example trench I've got here in this picture, it shows you just how much. And so what they'll do is you dig a great big long hole, or a very wide hole, or if you're very lucky and have a lake on your land, you can submerge the pipes, work in that. And you then have what's at least 1 kilometre of pipe in this groundwork. And then you bury it. And then you use very clever refrigeration technology. And if you think about what's going on as you compress gas in a fridge, if you touch the nozzle of a bicycle pump after you've inflated a tire, or if you deflate the inner tube and touch the nozzle, you'll notice it feels cold, because as gas expands, it causes cooling. If you compress the gas, it heats it up. And so if you work a bicycle pump vigorously and touch the walls of the bicycle pump, you'll notice that it starts to get warm. And so it's using the same sort of technology. And so what it uses is a pump, which and it's a load of water with antifreeze in that it pumps through this hose. And so this hose so that you supercool the air, the liquid that goes into the hose, pump it through this kilometre of hose, and by the time it's come back, it's heated up to the ambient temperature of the surrounding ground, which is typically up to about 12 degrees C year round. And then once you've done that, you then have some clever technology which uses this refrigeration principle to turn 100 litres of this water at 10 degrees C into 30 litres of water at 16 degrees C through what's known as a heat pump. And so that then gets sent off around the house. So you can either use it to keep the entire house at 16 degrees C, ambient temperature, through underfloor heating or heating pipes in the wall, and it pumps it through that year round. Or you can, and then you supplement that with additional heating where you need it. And so that might be having ambient heat sources produced by humans, via the electrical machinery we all like to use, TVs, and solar gain that you get from the sun. And that can often be enough to keep the property warm enough with no additional heating source. Or you can use the 16 degrees C to get the property up to a certain temperature and then supplement it with more standard heating sources such as gas central heating or log burning stoves. So it's fit and forget technology to a point, but the pump will need occasional replacement. You really don't want to get a hole in your pipe, otherwise you can forget the whole thing. You can do them up to 100 meters deep vertically, and so they started putting these ground source heat pumps in the foundation piles for for tall structures. Gherkin, I know the chap that was in charge of putting the one in that they've got in the Gherkin in London. Is it worth it? Well, it's 11 to 15k to fit. I would say it's only worth getting this if you happen to have a field. Don't mind your entire garden being dug up. Or alternatively, more sensibly, if you're getting it fitted whilst you're doing the foundation excavation for the building. Saves about £500 a year though, so it will pay itself off quicker than a lot of other measures. Air source heat pumps, well, these are pretty much exactly the same principle, but instead of using this clever refrigeration technology to warm up liquid that's come after being sent through the ground, it warms up a liquid that's sent through the past ambient air. These are effective down to about minus 15 degrees C, so will cope with even the worst of UK winters. And you can either use it to heat water, which goes off to a wet central heating system, or you can use it to heat air, which is then sent through air ducts to warm up the property. This lasts for about 20 years and actually is pushing it to getting close to being competitive with domestic central heating boilers, because domestic central heating boilers last for 12 to 15 years and cost £3,500 to fit, and then it'll cost you a further £800 minimum to heat the property each year after that. So even these things cost about 7k to fit and save you £300 to £400 a year, then actually they seem like a pretty good bet, and we really should see more of them, especially given that they only seem to look like air conditioning units, so the sort of thing that we're used to seeing on the side of buildings.